Okay, here we go. Let me take you line by line on how this code is executed, right? So this is a command for us to read this particular CSV file to R, read.csv. We are going to read this file called fraud underscore check. I want the header information, and the values here are separated using column in the data set. That is what comma separated value means, separated equal to comma. Even if you do not use this, there's not going to be a huge impact. Right? We are going to read this and load this into something called as fraud underscore check, this variable. So let me run this. I'm going to run this using control enter. So I have 600 observations and 6 variables here. If I click on that, it has executed this particular command called view fraud underscore check. Here we have 1, 2, 3, 4, 5, and 6 variables. And if I scroll it down, you see that there are 600 variables, 600 rows. Attach fraud underscore check does this, right? If I run this, from here on, if I want to refer to say taxable income, I can directly say taxable dot income and it will refer to that variable. Or if I say refer to this variable called urban, it's going to refer to that. However, if we do not attach, each time I need to do this. I need to say, hey, select urban from fraud underscore check. So what do you do ideally? Fraud underscore check dollar urban. Or if you want to read this particular column or variable called taxable income, so you do this. Fraud underscore check dollar taxable dot income. Right. So instead, each time I do not want to use fraud underscore check and then the dollar and then the variable name. So I'm going to attach that. Now, if I run this command head of fraud underscore check, what does it do? It is going to show you the first 6 rows of this particular fraud underscore check table there. If I say summary of this, it is going to look into each and every variable and then give a quick summary. If it's an attribute data, you see whether it's undergraduate, yes or no. These are the two categories within that. So, or levels basically. So it says that 312 is yes. These many entries have value yes for undergraduate, and 288 people have no as undergraduate, and so on and so forth. This marital status is a factor which has 3 levels: divorce, married, and single. And for continuous data, you have minimum value, maximum, first quartile, third, median, mean, so on and so forth. Now, just for our understanding, wherever the taxable income is less than or equal to 30,000, I'm going to mention a different, or I'm going to add a new column and call that as risky. Wherever the income is, taxable income is greater than 30,000, I say it's good. Just for our own understanding, that's it. Because that column wasn't there in the data set, we have added that. There is nothing else. So now I'm combining the fraud underscore check and category. So that ideally does this, right? For fraud underscore check, where we have 6 variables, it's going to add another variable called category. So let me run this command. Data.frame, and it's assigned to customer. So if I click on this customer, I see good and risky assigned. Yeah, categories are why. In real life, you will get to know what is your category also based on your historical data. So the bank might have already given loan to thousands of customers. Out of thousands of customers, 10% say default to the loan. That customer would become risky. So this historical data would be available with you in real world. This data set did not have one, so we have created one based on some logic. This logic you might say is weird logic. Yeah, it might be a weird logic. It's just for our understanding. But in real life, you will get that Y value based on your historical data. So if I look into simple table here on category, right? Category is your new column or variable which we have added. You see that 476 entries have good and 124 have risky. Since we have already used taxable income as our base to create risky or good categories, we can delete this taxable income basically. So I'm deleting that. Once we delete that column, I want to check what are the various columns available. And I know for a fact that out of 7, 1 is deleted now, which is taxable income. So I'll not have taxable income. Rest of the other things would be there. Set seed means each time, this is basically used whenever you sample the data. If you have a population and when you're trying to take a sample, you use the set.seed. Set.seed is used to ensure that each time you pick a sample, you pick the same sample. Right? So either 2, 3, 4, 500, 2000, 3000, whatever number you want, you can give. It's going to pick the same sample each time if you set the seed, right? So I'm setting the seed. Okay, now once I set the seed, what am I doing here? I want to sample. I want to pick a sample from 1 to n rows of this customer data set, and I want to divide the number of rows of customers to 2. So I want 50% as training data set. That is what this command does. So I'm running this command. What it ideally does is it is dividing the number of rows of customer by 2. So if you have 600, 600 by 2 is 300. So I'll have 300 entries, and I'm picking up a sample from those 300 entries. That is what it says. Even if you look into the length of the training data set, it says 300. This minus train means whatever data you have chosen for training data set as part of your training data set, do not choose those, choose the rest of the data for your testing data set. So there, rest of the data is chosen for your testing. So I select the length of test, and there I have 300 data points once again. So what are we doing here? You're taking the training data set and assigning it to training underscore data. All the rows, whenever you have the square brackets, right, it says rows comma columns. So all the rows of training data is taken and assigned to training underscore data there. And all the testing data is assigned to testing underscore data. Now I'll look into the names. It will give me the column names basically. All right. Now all the category of test data. So this category, right? All these categories from this test data, testing underscore data basically, right? From this. And you also notice that since we have picked up a sample, it has picked up randomly sample, right? Even if you look into the training data, which was sampled, right? You do not see the numbers in sequence. Look at that. 1, 1, 1, 4, 2, 1, 3, 4, 3, 1, 1. So it was randomly selected. That is what your sampling has done. Now, so all the categories of your testing data set is assigned to a new variable called testing underscore high. Right? So we have done that. So where will we use testing underscore high? I'll let you know. So if you look into the length of testing underscore high, it should be, I believe, 300 only. Okay, my bad. We have not run this command. Now it's 300 there. If you look into the dimensions, 300 observations, and you have 6 variables in the training data, and you have 300 observations and 6 variables in your test data. You can also look into the summary. It's extremely important to look into the summary, right? Do not forget that. Even in your interviews, do not forget this. This is a basic premise for you to proceed with your further analysis. You need to do your descriptive analytics first. Elementary steps. Now, library tree. Tree is the library which you need to install and load for you to run this decision tree. Now, tree is a command. Here, from this training data set, training underscore data set, I am selecting dollar category. That means this is my Y, and Y till Dot means I'm selecting all the other variables as input variables or x's, x values, right? Input variables. This is the only y tilde x. That is how you do. From which data set? Training underscore data. So let me run that. Once we run this, we are plotting this, and here is a plot which you see, right? And pretty equal to 0 means it will provide the corresponding labels. So there you go. This is how it is. The same decision tree concept. Each time it is split based on the gain value. Now once I have built the model, what should I do? I need to test this. I'm testing this on testing data, testing underscore data. Type is class means classification. Predict is a command to test this anyways. So there we ran the model. But now I want to know how many have been misclassified. So in this you have the data, right? You have predicted using the tree model on the test data, and you get some outcome, right? On 50% of the data. Testing data is 50% of the data. Now remember we have done something around testing underscore high. I'm going to compare that testing underscore high with this decision underscore tree. So this is something which you have predicted. Testing underscore high already has the true values, right? Predicted versus actual values. I'm trying to compare. How many of your predicted values are not equal to the actual values? And you want the mean of that. Mean turns out to be 0.22. Now my question to you all is, should the mean value here be less or more? Less the better or more the better? What do you guys think? This mean value, less the better or more the better? You did not get the mean part. Monica says more the better. No. So I believe you guys are not conscious. So what are we doing here? We have first built the model, prediction model, right, or classification model, whatever model we have built that. Once we build the model, the next step here is to test whether our model is accurate or not. So what did we do? Remember, we initially had 600 data point, 600 observations. We have divided those 600 into. Now are you able to hear me, Aditya? Yeah. Okay. So yeah. So initially we had 600 observations. We have divided these 600 observations into 300 for training data and 300 into your testing data. Okay. Monica says voice is breaking. Is my voice breaking at your end also, Aditya? No. All right. Monica, that means problem at your end, probably. So training underscore data has 300 data points. So I'm going to build my model based on this training data. And once I build my model based on the 300 data points or observations that I have, I'm going to test the accuracy of this model using the testing data. So my entire data set, historical data that I have, I've divided that into 50% training data and 50% testing data. I've built my model on training data. I want to test my model on the accuracy. So I have ran this command called predict. So it has predicted some, and the outcome is stored in decision underscore tree underscore prediction. Whatever is the outcome which we have predicted, right, should be compared with the actual values. Now this decision underscore tree underscore prediction would have actually predicted something. Let me. So it has given all these things, right? 600. 600 for all the 600 entries, it has given whether it's good or risky, and things like that. Now, are these values in line with the actual values or not? So what are we doing? These values, decision underscore tree underscore prediction, right? Are they equal to the actual values which we have stored in testing underscore high or not? And here, what are we doing? We are checking on whether the predicted values, we are checking the average of predicted values not equal to the actual values. Predicted values and actual values are in testing underscore high. If you look into testing underscore high, right? Let me type that. Testing underscore high also has actual values. So these values are compared with the predicted values. Here we have predicted values, here we have actual values. I'm going to compare one on one. Wherever it is compared and it's correct, it's taken as um, 1. Basically, wherever it doesn't match, it's taken as 0. Oh, sorry. Wherever it has matched, it's 0. Wherever there is no match, it's 1, basically. Right? Now I take the mean of that, average of that. I get 0.233. The low, the better, right? The number of mismatches, the less, the better. Huh. Simple, yeah. Yeah, so you get this value. That's 0.233. Yeah, correct. Now, if you feel that, no, this accuracy doesn't suit me, I want a better accuracy, if your management says so, you once again set a different sample and you do something called as cross validation of the tree, right? When you plot the tree, let me plot the tree and show you what happens. Um, Here, if you have a steep bend there, if you have a steep bend, here type equal to B means I want both points there and also lines. If there's a steep bend, then that is a count that you take for your split basically. So you're not going to split your decision tree until n levels or 4 or 5 levels. Instead, I'm going to split my decision tree only till 2 levels. So here is a split, so I'm going to stop there. So that is why I've taken best as 2, and this is prune dot miss classification, right? And then I'm going to run this command. Once I plot this, I'll get a new decision tree, right? And if I want the values associated to each branch there, I say pred equal to 0, I get those values. So all of a sudden you see that your decision tree has been condensed, right? And now if I predict and if I look into the average misclassifications, it shows 0.22 as opposed to 0.23. So you have increased the accuracy of your model just slightly. Now it's a decision that you and your management will jointly take on whether 0.01 accuracy increase is better, or you want to go with 0.23 only and go with this model, this classification. Yep. Okay, I'll just stop here. Do you have any doubts, any questions on decision tree? Your random forest is the same except for uh, running multiple decision trees. That's it. Not clear on pruning. So what does pruning mean? If my, say here my accuracy is so much, means 23%, I should not be taking saying that. So 0.233 is the average, right? On an average, so many things do not match. Your predicted versus actual do not match in so many places. So if your management comes to you and says, I'm not going to accept this model which you have built. I want the accuracy to be further increased. Just as an example, right? If your management says so, then what would you do? You'll have to increase the accuracy. So in order to increase the accuracy, what you do is you look into a plot which is run using cv.tree, right? This command is used to run that particular plot. Once you draw this plot, which appears like this plot is just to check on whether there is any steep bend or not. Wherever there is a steep bend, you take that count. For example, here there's a steep bend at the second point. This is a way to increase the accuracy of your model. How do you increase the accuracy of the model? This is the technique, right? So you look into this pruning tree, which says 1, 2, and then there is a steep bend. 1, 2, and then there's a steep bend. So I stop at 2, and now when I want, now if I were to increase the accuracy of the model, I need to build the model in such a way that there are only 2 levels of classification. One is city population and second is work experience, and I stop there. And this is the best accuracy which I can achieve, by the way. What does your plot here say? It says that 1, 2, and then there's a steep bend. That means if you want the best model based on accuracy, the best that you can do is splitting your decision tree to 2 levels. And that is what your best equal to 2 says. That's it. All we have done here is, instead of stopping here with the model which we have built, we have tried to check, hey, what is the best scenario? This model, okay, is okay for me. But if I were to increase the accuracy of the model, how best can I increase that? What is the best way to improve that? For that, what did I do? I've drawn this graph plot. This is called as pruning. I checked where is uh, I mean, where in this plot we see a steep bend. We see it here at the second point. And this says that if you give best equal to 2 in your command, you'll get the best model. And your accuracy cannot increase beyond that. Based on that, when I have done the same thing of predicting the model, running the model, and looking into the mean misclassification, I get a value 0.22. Kind of in this model, yes. Yep. So do you guys have any doubts before pruning? Yeah. Before pruning and after pruning, the only difference that you see is the number of splits will reduce. The number of levels that you split will reduce that. So here, how many splits do you have in the initial model? 1 level, 2 levels, 3 levels, 4, 5, 6, so on and so forth, right? However, in this, you have only so many levels. So what is the inference that you draw from here? If the new person is applying for a loan, is coming from a city whose population is less than 58233, right? And if he has a work experience of less than 7.5, right, then he's good. Sorry, if a person is coming from a city population which is less than 58233, then he's good. If a person is coming from a city population which is greater than 58233, then you look into work experience also. Here, if the work experience is greater than 7.5, it's good. If it's less than 7.5, you once again check, Is his work experience less than 6.5 or not? If it's less than 6.5, it's good. Greater than 6.5, it's a risky kind of right. In that way. That's the inference. However, your prediction model here, when you say predict, right, that itself will say whether the new entry is risky or good. One example, the new person is coming here. He has undergraduate, yes, marital status single, city population some XYZ, work experience, urban, right? Until here, you'll not know the category details. So if it's a new person, I'll create a new CSV file, for example, Aditya. Assume that I've created a new CSV file only with 1, 2, 3, 4, 5 values. So I'll have only 2 rows. One row will have the header information. Second row will have these 5 values, right? Assume I have one new person who has applied for loan. This new person's details are entered in a CSV file and loaded to your R. Assume that is what we have done. Now what will I do? I'll simply go to this command here. I'll say predict decision underscore tree underscore p underscore model, and instead of testing underscore data, I'm going to give the name of the new file which we load. Let's create a new CSV file with only one entry, one row, and load it into R. That file will anyways have a name, the new file that you're going to load. Here, give that name and run this command. Once you run that command, use this, right? Because you're loading the predictor value into this. When you run this, here you're seeing multiple things, right? Good, risky, and all that. There, if you only have one person, you'll see only one value, whether it is good or risky. That's it. Absolutely. Yeah. You can also enter the values directly, right? That you can create it. But in reality, yeah, instead of testing underscore data, you give the variable names. We can give values for all the variables. Yeah, absolutely. In the same order, undergraduate equal to so much, marital status equal to so much, city dot population equal to so much, work experience equal to so much, urban equal to so much. Yes or no? Right? What is it? So it's certainly of prediction. I didn't get you. What do you mean by that, Aditya? No, it's not certainty, right? You don't have any probability associated with that. You'll just get direct value whether it is good or risky. You'll not get any probability. And you can just do this.
Yeah,
You'll
Madhu. What I meant to say was, what I meant to say was that answer probably once we run that predict command, we'll be getting good, either good or risky. Meaning,
That's it.
based on the values that we are giving, okay, it is a this person will not fraud or he's a risky person.
Absolutely.
So which means that is certain that okay, I should not give him the loan or
Exactly.
whatever, right?
Yes, yes.
But here in logistic, it will say let's say 80%. So we don't know if 80% is good or bad, right?
No, no, it will say 80% good or 80% bad.
Okay.
You can actually build a complete table in logistic regression and say good, bad, what is the probability associated with that.
Okay.
There is a 90% chance that he is a good customer given the excess or given the input values.
For logistic.
For logistic, yes.
So here it's like I mean
100%. Assume that it's 100%.
100%.
Yeah.
Ah, I assume 100%. Yeah, we can safely assume, right?
Yeah, yeah, yeah.
Okay, cool. That was actually my doubt that was running in my mind.
Okay. All right. So I'm going to stop this recording. I'm going to share this recording by tomorrow. I'm at ExcelR office. I'll start now. Okay. Thank you, friends. Tomorrow we'll connect and probably get back to our regression concepts once again. Thank you so much.
Oh, thank you.